Alright, hello Mr. Luong, this is FRQ number 4. Part A, we're asked to draw a free body diagram showing all the forces acting on the car. And also an arrow indicating the direction of any acceleration. So, let me just draw the system real quick. Alright, so there's a car right here. There's a car. And this car has the forces Fg acting upon it. The forces Fg pulling it towards the Earth's surface, so downwards. And Fn parallel to the surface which the car is touching, so Fn right here. These are the only two forces. And for acceleration, there's only centripetal acceleration pointing inwards. You see? Because it is moving in a circle, therefore there needs to be an acceleration centripetal. But additionally, Fn of x is Fn is composed of the two components, Fnx and Fny. And the only force in the vertical x direction, or in the horizontal x axis, is Fn of x. So therefore, since there is no other force in the x axis, there's no force to act against it. Therefore, there must be an acceleration towards the middle, right? And the reason why there's no vertical acceleration is because it states that the car is driving horizontally. So therefore, Fn is counteracting Fg, or Fny is counteracting Fg. And for part B, we're asked to derive an expression of the normal force acting on the car, given the quantities. So what we need to do first is use the formulas. Fn of x is equal to Fc, and F of n of y is given by mg. And the reason for this... Oh, do you need something?
No, I was looking for something.
Alright. Oh my god. Alright, so, and F of n of y is equal to mass times gravity. And the reason why we use these two is because F of n is given by the formula square root of F n y, or x I guess, it doesn't matter which order, squared plus F n of y squared. And this is because F of n, right here, as you can see, the block, right, F of n, is given by the components F of n of x and F of n of y, and that makes a triangle, and it's a right triangle specifically, and therefore we can just use Pythagorean theorem. F of n squared plus c squared is equal to b squared plus a squared, where c is F of n, a and b are F of n of x and F of n of y. So F of n of x is equal to fc. Well, we know what F of n of x is fc, and fc is given by mass times velocity squared over r. But we can't use r here because it tells us to use theta, and there's no inclusion of r. So how do we find r? Well, the theta given is only this one. So what should we do? Well, we can think of this. We can solve this just by using some trigonometry. This is specifically to understand what is happening with theta. Because, alright, so theta right here, well, that's a theta, right? That's a variable. Well, we know here this is 90, this is 90. And this is equal to, because a triangle is made up of 180, that, let's just do a question mark for that. 90 plus question mark is equal to theta. And if we, question mark plus theta. And we can just isolate for question mark, which gives us 90 minus theta, right? So let me replace that with 90 minus theta. So what we know about this is that this is also 90, right? Because this is 90 degrees if you look at it like that. Like this is a straight line, 90 degrees. So if this is 90 and this is 90 minus theta, and we know that a line and the angle of 9 is 180 degrees, right? So we can just do the same thing. 180 is equal to 90 plus 90 minus theta plus something right here, right? And to solve this, we can just isolate 90 minus 180, so it becomes theta is equal to question mark. So we got this angle right here, theta. Angle is just theta, right? So therefore, we have the theta that we need to find r, because the r that we're trying to find in this scenario is, where is it? R. Yeah, because we need to find r, right? And r is this distance, right? And to find that, we can just do h right here, or h of, let me check one more time, right? Yeah, because we're just trying to find this h and this r. Oh, I didn't even have to do all that. But anyways, yeah. Alright, so if we were given this, then we could, okay, that was stupid. Alright, I'll probably get rid of that. So anyways, h and r. To find r, we have the value, we are allowed to use a variable h. And what we know about this with using these values is that tangent is given by y, or x over y, right? And tan theta is given by x over y, right? And here, x is r, and h is y, right? So we have h tan theta is equal to r. Oh, that should be lowercase. These should be lowercase, right? So we got the value for r. So we can just plug that back in right here. So we got Fn of x is equal to mv squared over h tan theta. And for Fn of y, this is also very simple, because Fn of y, it should have been Fn of y is equal to Fg, right? Because those are the only vertical forces and components. And we know that it is not, the system is not moving vertically at all, so it's in a standstill. So these two forces are acting upon against each other to make it zero, therefore they're equal to each other, and we just found Fn y is equal to mass times gravity. So we just plug that into into this function, and we get Fn is equal to square root of mv squared over h tan theta squared plus mg squared, or yeah, just mg squared. These should be lowercase. I don't know why I put power. Does it say m is? Oh, they tell us to use a big M. My bad. So these, it should be capital M, capital M. This should be capital M. Right, and that's our formula for part B. Alright, for part C, we are asked to derive an expression for the centripetal force, Fc. Well, we already found Fc, right? Fc is just Fn of x. And Fc is just equal to mv squared over r. Right? Wrong one. And v squared over r. And we found that r was just h tan theta. So, all we need to do here, we're done. That's actually just what we needed to find. We already found it earlier, and we just bring it back here. Alright, so let's go on to part D, which asks us to find the derive an expression for v. So we're trying to find velocity here. So what we know about v is that v is given in the formula right here, Fc, right? So Fc, which is equal to Fn of x, is given by mv squared over r. So, well, r is tan theta, right? So we'll just already do that real quick. Just like, Actually, no, that's wrong, because we should go step by step. And Fn of x is given by Fn cosine theta, right? Because if we go back up here, theta is here, and Fn of cosine is just r. Or Fn, this is Fn, and this is Fnx, that's the x-axis. X-axis, what is it called? Component, x-axis component. There's the y-axis component, and Fn, right? So this did come in useful, but right? So f of n is equal to f of nx is equal to Fn cosine theta. And what we know about Fn is that Fn of y is given by mg, right? We already stated this earlier. Or Fn, let's do this, F of g. And f of n of y is equal to mass times gravity. We already stated this earlier, right? So f of n of y is just f of n cosine sine theta. So look up here, it's just a sine, right? Sine is given by y, or yeah, Fn is cosine theta is equal to opposite Fn y over hypotenuse, which is Fn, and then shoot, and you just multiply it over here. So Fn sine theta is equal to Fn y. No, my gosh, I'm so dumb. Sorry. Let me say that again. F of n is equal to Fn of y. Right, because it's opposite over hypotenuse. No, I am so stupid. I am so sorry, Mr. Wong. I was correct the first time. It's opposite over hypotenuse, Fn, and Fn of sine theta is equal to Fny. So yeah, that's what we got here, right? That's what we got here. F of ny is equal to Fn sine theta, which is equal to mass times gravity. So we just want to isolate for Fn, which is m times g divided by sine theta. And we can just plug this back in here, and this gives us mv squared over r, and we'll solve for r. We already solved for r, right? We know it's h tan theta is equal to mass times gravity over sine theta times cosine theta. And what we know about sine theta times cosine theta is that is cotangent, right? So we'll just do times cotangent theta is equal to yeah, right? And what we know about this is easy to think about like this. Cotangent is equal to 1 over tan theta, right? So we'll just write tan theta here. And since we have mv squared h tan on here, what we can do is cancel out the tan thetas and also the n's. So what we're left with is v squared is equal to g times h, and we just have to square root both sides, and we get the velocity is equal to square root of g times h, and that's our formula for velocity. And that's it. Alright, now for part E, we are to assume that there is friction and that the coefficient of static friction is mu s. So the car does not slip. Alright, so we are asked to derive the function for the maximum speed in terms of r, g, mu s, and theta. Alright, so what we need to do for E is we need to find alright, so first we need to find Fc, which is equal to Fsx plus Fnx. And the reason why we want to find Fc is because Fc gives us mv squared over r, right? And that has v. And the reason why we're using Fs plus Fnx and not minus is because the friction force is acting with this, and the reason why the friction force right here is acting with the force is because when we look at this system, and when it's speeding up, right? When the car is trying to reach its maximum speed, the car is speeding up, right? And when the car is speeding up, it moves upwards, right? And yeah, therefore it moves up the slope. And since the force friction always goes against the motion, it's gonna try to go down the slope, right? And if it goes down, it's going southeast, right? With the x going towards the middle, towards the middle, and right, it's going in the same direction as f and x. Therefore, we have to add these two values. Right. So now that I explained why, we can just derive the formulas. F is equal to mv squared, r, and is equal to, and here we can use r. So I'm not going to do 10. So Fs is equal to Fs sine theta, and Fn x is equal to Fn. This should be capital N, Fn cosine theta. Right. And yeah, the reason why this is sine is because fs is going this downwards, and if you look up here, this is going downwards, and ffs is this formula, right? If you look at this, it should be this, right? Or I guess you can just look at it like this, right? Because f of x is going down this line. So if f of s is this slope, f sine is f of sx is this, right? And that is sine, because this is the hypotenuse and this is the opposite. Sine theta gives us opposite, so fsx over the hypotenuse fs. So fs sine theta is equal to fsx. So that's why we have f of s sine theta, right? And additionally, f of s is just f of n times mu s, right? Because f of s is just yeah, that's the definition, right? Because the force of friction is just given by the natural times mu s, right? So we can just do that and multiply that by sine theta plus fn cosine theta is equal to mv squared. But now we're stuck because we don't know what fn is, so we have to find fn, right? And the way to find fn is to use fn y, which minus fg minus f of sy is equal to 0. And the reason why is because it is still moving in a bane curve, and it's not slipping, so it's not moving upward, it's not moving vertically at all. So what we're gonna do is, alright, so let me explain why fsy is moving against the system. It's because if you look back here, actually let's just go down here. We already say that f of s of y is moving southwest, right? So it's going downwards and westwards. And since fg is negative in our system and ff is positive, fg is also pointing downwards, right? Right, fg is pointing downwards, fn is pointing upwards, and fsy is pointing downwards also. So f of s we're just gonna say is negative, and as f of g is also deemed negative in this equation or in this system. So we're just gonna do f of, oh my gosh, I keep using lowercase n. Alright, fn of y is just fn sine theta. Fs is just fn mu sine cosine theta. And fg is just mass times gravity. I guess the right way to do it would be to first state that fs is just cosine theta, fsy is just cosine theta, and it's the same thing up here. This is f of sy, right? This line, and that's adjacent. This is adjacent. This is hypotenuse. So cosine theta gives us adjacent over hypotenuse. Cosine theta gives us adjacent f and y over fsy, fs. Right. So fs is fs times cosine theta is fsy. So now that we have that, we can also replace this again, like we said earlier, with fn times mu sine times cosine theta, because this is the static friction is given by the force natural times mu s, and then we can just move this to the other side because that makes it a bit easier. Now that is on the other side, we can now isolate for these values. So fn is fn sine theta minus mu sine cosine theta is equal to mg, right? And we can just divide both sides by sine theta minus mu sine theta, mu sine cosine theta, or sine theta mu s cosine theta. Yeah, I make mu s here, mu sine. Whatever I said. Right. So what we're left with is fn is equal to mass times gravity over sine theta minus mu s cosine theta. So all we have to do is just plug it into this formula, and I'll put that here. mv squared over r is equal to fn times mu sine times sine theta plus fn cosine theta. And I'm gonna group these up together to make it a little bit easier for us, as mu s sine theta plus fn cosine theta, or just cosine theta, right? It's just this, equal to mv squared over r. And now we can just substitute fn in, which is mass times gravity over, let's do mass times gravity times mu s sine theta plus cosine theta over sine theta minus mu s cosine theta, right? Is equal to mv squared over r. Now what we can do here is just cancel out the m and multiply both sides by r, right? That'll give us v squared is gr, gr mu s sine theta minus plus cosine theta over sine theta minus mu s cosine theta. And the last step we have to do is just square root both sides, and that gives us v equals gr mu s sine theta plus cosine theta over sine theta minus mu s cosine theta, and that's v max. Let's write that for every one of them, just in case. Max. Right, and that's part E done. That's the formula that we need to find. Alright, wait, no, yeah, that's it. Alright, so for part F, we're basically doing the same thing, except now, instead of doing f of nx plus f of x, we're doing f of nx minus f of x equals fc. And the reason why we do this is because now that we are finding v min, the car is slowing down, right? Or it's slowing down and therefore moving down the slope. And so the force friction always goes against the motion. Since f of n is the car is moving downwards, the force friction will try to make it go upwards, right? So therefore, f of sx is moving in opposition of f of nx. So now we're going to do the same thing again. F of n is fn cosine theta minus f s sine theta is equal to mv squared over r, and fs minus fn, like we talked about before. Fs is given by multiplying the natural force with the static friction constant. And then now we have to find fny, or fn, using fny. This time, adding fsy minus fg is equal to 0. Because as you can see here, this is going northeast, it's going in the upwards direction, and fn is in the upwards direction, and fg is in the downwards direction. Fn is working with fn. Alright, so fn is given by fny is given by fn sine theta plus fs cosine theta minus, or is equal to fg, and fn sine theta plus fn mu s cosine theta is equal to mass times gravity, and fn is equal to, and we're going to do the same thing. We're going to group fn together so that you can take it out and you're left with this, and we can isolate for fn, giving us fn is equal to mass times gravity, or sine theta plus mu s cosine theta. Now all we have to do is plug it into this formula now, and we're going to do the same thing. mv squared over r is equal to fn, and I'll group these together as well. Cosine theta minus mu s sine theta, and this will be and then we plug it in. We have mv squared over r is equal to mass times gravity over or times cosine theta minus mu s sine theta over sine theta plus mu s cosine theta. And all we have to do, cancel out, multiply both sides by r, so that multiply for r, and then we have to square root both sides, and we're left with v min is equal to g times r, or square root of g times r cosine theta minus mu s sine theta over sine theta plus mu s cosine theta. Now I'll put v min in all of these as well. And that is how you find v min. Alright, for part G, we're asked to find the net force acting upon it. So part G, we're asked to find the net force. We're trying to find the net force, right? And we're trying to prove that it is equal to cotangent theta plus mu s over 1 minus mu s cotangent mass times gravity. So how do we get delta, sigma f? Well, sigma f is given strictly by fc, and the reason why is because f of y just does not exist. So all there is just f of x, or the force sigma f in the x-axis, because all the because since the system or the car doesn't move upwards or downwards, there's going to be no acceleration. It's just going to be constant, and therefore there's going to be the net force is going to be 0, right? So sigma f is equal to just f of fxy, or sigma f is just equal to sigma fx, which is equal to fc, right? And that is equal to mv squared max over r. It could be min or max, but min gives us the function that we're looking for. So, or max is the function that we're looking for. So if we have mv squared max, we have to plug in. So we already found the v max, right? Right here. One of these, right? v max, I think it's this one. No, that's not the right one. Yeah, right here we found v max. So we're just gonna plug this in to the formula, and that's just square root of rg cosine theta minus plus mu sine theta over sine theta minus mu s cosine theta all over r, and you have to square this. And since we're squaring it, we can just cancel these two out, and you're left with m over r times r. Oh, never mind. We can also cancel out the. Actually, let me just write it all out. Rg cosine theta plus mu s sine theta over sine theta minus mu s cosine theta. And here we can cancel out the r's, and then wait. We cancel out the r's. Yes, we do cancel out the r's, and then what we're left with is m cosine theta plus mu s sine theta over sine theta minus mu s cosine theta. And now, when we look at the formula that they give us, it is we have to get to, oh, I forgot the G here. So what we have, sorry, it should be capital M. So what is similar here is that we both, so the function that we want to get to is mg cotangent theta plus mu s sine theta over 1 minus mu s cotangent theta. And what we want to get to, right? Because we already have mg for both, and we have mu s here. And oh my gosh, this is not supposed to be there. Okay, so this is what we're trying to get, right? And what we know about the relationship between all these is that if you just divide everything by sine theta, you will get all these values. So if you divide sine theta by sine theta, you get just mu s. Mu s sine theta by sine theta, you just get mu s. Divide cosine by sine theta, you get cotangent theta. Sine theta divided by 1, sine theta. Mu s cosine theta divided by sine theta, cotangent theta. So what we're gonna do here to get to here, so that we can get to there, is we're going to multiply both the top and bottom by 1 sine theta, 1 over sine theta, 1 over sine theta. And this will allow us to do mg is just distribute this to everything on the inside. So it becomes cosine theta sine theta plus mu s sine theta over sine theta over sine theta over sine theta minus mu s cosine theta, that got deleted, cosine theta over sine theta. And if we simplify this, we do get the formula mg cotangent theta plus mu s over 1 minus mu s cotangent theta. And this is the formula that they want us to prove, so we have the proof there. And that is it for this video. Thank you for watching, Mr. Wall.